Hello there. Alright, in this video, we'll be looking at how to determine whether a function is an even function or an odd function. Now, before I begin to treat some examples, let me just give a very brief definition about what we mean by saying a function is even, a function is odd. So, now definition, or let me just say a very short definition is that a function f, is said to be even if it satisfies this condition, which is f of negative x equals f of x. That is, the function value of a particular element in a domain is also equal to the function value of the negation of the original element. And also, a function is odd if it satisfies this condition here, and that is the function value of negative x equals negative f of x. That is, the function value of the negation of the element is actually equal to the negation of the function value of the original element. Now, the difference between the function value, that's the even function, and the odd function is that for the even function you have a positive sign here, but for the odd function you have a negative sign here. So this is for the odd, while the other is for the even. So you should just know the difference. So we're going to go ahead and try some examples and then see how we can determine whether a function is even or a function is odd. So let's see this first example. So I want to check if f of x equals, so let me call this example A, equals 2x to the power 4 minus x squared. So I want to see if this function is even or odd. Now, to check, anytime you want to check whether a function is even or odd, just punch in or replace your x with negative x and then see which of the condition it satisfies. So this is f of x, so I'm going to punch in f of negative x. So this is going to give me 2 into negative x raised to the power 4 minus, then this is x, which is replaced with negative x all squared. And this is going to give me 2, then negative x to the power 4 is the same thing as x to the power 4, then minus negative x to the power 2 is actually x squared. And then this is going to give you 2x to the power 4 minus x squared. Now what you'd observe is that what you have here is actually the same thing as what you have here. That is, this is equal to f of x. So I've been able to show that f of negative x equals f of x. So this actually implies that f is an even function. Let's go ahead and try another example. So B, so given a new function, let's say g of x equals x divided by x squared minus 1. So we want to see if this function is even, odd, or neither of them. So like I said, to always check if a function is even or odd, just replace what you have here with the negation of it and then see what it results to. So what we have here is, so it's going to be g into, so we're going to replace x with negative x. So you have negative x equals, so x is replaced with negative x divided by, so you have negative x all squared, then minus 1. Now this is going to give you negative x divided by, now negative x all squared is going to give you x squared minus 1. Now this could be written as negative into x all over x squared minus 1. And then you'd observe that what you have here is actually the same thing as what you have here. So this is just like saying equals negative. Now what we have here is g of x. So I've been able to show that g of negative x equals negative g of x, which is actually equal or the same as the definition for an odd function. So therefore we would say that, so therefore g is an odd function. And let's try one more example before we call it quit here. Now the last example here says, if you're given h of x to be equal to 3x cubed plus 5, and then you want to check if it is even or odd, or neither of them. So let's see. So we said we replace the x with negative x, so what we would have is h of negative x equals, now this is going to be 3 into, so we have an x here, so we replace it with negative x, so to the power 3, then plus 5. So this is going to be 3. Now negative x all cube is actually equal to negative x cube, then plus 5, and then this is the same thing as negative 3x cube plus 5. Now the very first thing you observe is that when you compare this and this, they are not the same thing. So this does not equal to h of x. Similarly, when you check h of minus h of x, which is equal to, now negative of h of x is negative 3x cube negative 5. Now this is negative 3x cube negative 5, but what we have here is negative 3x cube plus 5, but here is negative sign. So this also implies that it does not equal to the negation of the original elements there. So that implies that this is for the even, this is for the even condition, and then this is for the other one here which we have here is for the odd condition. That is this one here is for the odd condition. So it doesn't satisfy, according to what we've just shown, it does not satisfy the even condition, and it doesn't satisfy the odd definition. So that implies that h is neither an even how do I write that? Okay, is neither an even function nor is it an odd function, nor an odd function, neither of them. So that completes the problem.